All right, applied pre-cal. You have survived graphing, substitution, and elimination. We're going to move on to some of the more complicated examples. In this case, we're starting with substitution part 2. There's also elimination part 2 that we'll look at. So you could see, we're going to work with an example, you could see some sort of function like this one here. If there's a system, you'll see the function symbol, whether it's f of x or some other function like g of x, h of x, whatever. And then you'll see an open brace and all of the equations that are part of that system. So in the system of f of x, I have these two equations. The first one is 1/2 x plus 2/3 y is equal to 1. My second is 1/4 x minus 1/3 y is equal to 5/2. Now you could use substitution part 1 or elimination part 1 to try and figure out how to work with these equations. If you have access to a graph, you can graph these and you'll be done in like 5 seconds. But what if I'm asking you to prove this using substitution part 2? What could you do to solve a question like this one? Well, if you're doing substitution, you need to figure out what you're substituting. So it's a good idea to pick one of your variables. I'm going to pick x just for the sake of argument. It's the first one I see. You can pick y if you wanted to. You get the same solution as we've seen previously. The problem with my x is that one of them is 1/2 and one of them is 1/4. They're both different. So I need to make them both equal to the same value in order to substitute either one in. Now, I'd also like my numbers to be nicer. It doesn't have to be that way, but I'd feel better if my numbers were nicer. So what is a nice number that I can make both of these fractions? Well, this comes from practice, right? I could do this quite a few times through, doing practice through my textbook or through other practice as well. And I might recognize that, I could multiply this top equation by 6 and multiply this bottom equation by 12. Those aren't random numbers. If I multiplied the top equation by 6, I'd end up with 3x. If I multiplied the bottom equation by 12, I would end up with 3x. So I'd have something to substitute. But also, if I multiply the y coefficient 2/3 by 6, I end up getting a nice number of 4. And if I multiply the y coefficient down here, 1/3 by 12, I end up getting a nice coefficient of -4. So I'm getting some nice numbers if I pick nice numbers to multiply by. Now, if that goes over your head a little bit, that's okay. You can pick whatever number you want. Ideally, you want 2 of your coefficients to be the same. In this case, I've chosen x. I'm going to multiply my top equation by 6, just because I know it gives me nice numbers. And I'm going to multiply my bottom equation by 12. Again, because I know it's going to give me nice numbers. You don't have to do that. Okay, you don't have to if you don't want to. For instance, if you recognize that 1/4 is half of 1/2, you could just multiply this equation by 2. And you'd end up with some ugly numbers, but it would still work. You can still do substitution that way. Let's work with these numbers though, because I want them to be nice. I'm going to rewrite all of these equations, except I'm going to have everything on the top multiplied by 6 and everything on the bottom multiplied by 12. Okay, so just doing it piece by piece, I end up with 3x plus 4y equals 6. Multiply the top thing by 6. If I multiply the bottom equation by 12, I end up with 3x minus 4y equals 30. You might be recognizing that, hey, I could probably do elimination now because I have 3x and 3x. You could subtract the second equation. Or you could just add the 2 equations and eliminate your 4y's. And that's true, you could do that. We're going to do that in elimination part 2. Instead, we're going to rearrange both equations. So we're going to set them both equal to 3x. So the first one becomes 3x equals 6 minus 4y. The second becomes 3x equals 30 plus 4y, which means that all 4 of these terms are the same thing. So now we can set one equation equal to the other. 6 minus 4y equals 30 plus 4y. It's time for some algebra, and we can solve that algebra on the board. Okay, so I've just taken that equation at the bottom, rewritten it at the top, and we'll do some of the algebra. So by subtracting this 4y from the right-hand side, I have to subtract it on the left-hand side as well. That's where I get this -8y from. And because I'm collecting my y's on my left, I want to get rid of this +6. So I subtract 6 from both sides. I end up getting 30 minus 6, which is 24. Then I can divide both sides by -8. That would isolate my y value. I end up getting y equals 24 divided by -8. And 24 divided by negative 8 should give me negative 3. Don't forget your negatives because that will make things a little bit awkward when we solve for the other variable. I want to know what x is. Well, I can pick either one of my equations and I can just plug negative 3 in for y and that will tell me what x is. So I'm just going to choose the first equation. It's pretty simple and then we'll see what it looks like. Okay, so I'm just going to be plugging in that negative 3 that we just solved as y in for my y value. I'm using my first equation to solve for x. In fact, I'm actually using the first equation that we rearranged because it already starts to isolate x for us. So I've rewritten the equation here, then I plugged in the negative 3 for my y value. Negative 3 times negative 4 gives us a positive 12. That's where this positive 12 comes from. 12 plus 6 gives us 18. We're left with 3x is equal to 18. So you divide both sides by 3 and you end up with x equals 6. So whatever this was solving for, I know that my x-coordinate is 6 and my y-coordinate is negative 3. That's using substitution. Now you might recall from the last couple of videos, substitution part 1 and elimination part 1, elimination was a little bit heavy. There's a lot of stuff going on. This time substitution is a lot of stuff going on, and elimination part 2 will show you that sometimes elimination is a little bit easier to do. So we'll get to that shortly. That'll be in the next part. Otherwise, I've got some practice for you to try out. That'll be showing up right over here. And as always, any questions, give me a shout. We'll take things from wherever we are.